Zilla, and Ray Kelly, who's not here with us, but also very instrumental. As well, Tom Holm, Bruce Quirk, who put the excellent technical program together. Take just a few minutes now to give you some idea about what's happening at ASPRS. Many of you are ASPRS members, and thank you so much. As many of you know, we've been going through a few years now of restructuring and revitalization, and I'm really happy to say that it's been working. We always have improvements to make, but the state of the union is sound, and I'm so happy to be able to say that. One of the first things that made that possible was really taking strong control of our finances. And we have put ourselves on a lot stronger fiscal footing. We're on our way to a balanced budget in 2018, and that makes us very, very happy. We have a strong program. Some of our strengths are in the areas of, for example, certification. We have, as many of you know, that are certified and for various professional categories such as photogrammetry, remote sensing, GIS. We have two new strong categories that we've developed kind of in this leading edge in LIDAR and also now in UAS. And we rolled out our UAS certification just this last year. And we were so pleased that when we kicked it off at the UAS symposium, we were able to certify 14 individuals as professionals in UAS. It is a board certified certification. CESB board certifies us, so we're really proud of our certification program. I think it's a strong program. In addition, we are able to give tens of thousands of dollars of awards and scholarships every year to our students, and primarily students and early career professionals, and that really helps for, fostering our field. We're proud of that. We put together a brand new conference plan, which is already started, but you'll really see the beginning of it here in 2018. And this new conference plan is that we're co-locating with other strong industry events. And we think that this is going to be very good for our members. In particular, it gives us the ability to not to have to focus quite as much on things like the venue and in the hotel and the meeting space and all of those tricky details, and leave those details to professionals that's what they do, and then gives us the ability to really focus in on the technical program, which is our strength. So I think it's going to be a win-win for our members. We're excited about that. Another thing that I think that we're all very proud of is our strong publications. Many of you get the PE&RS journal, and that has just been raising in its quality, and we're really proud of that. And in our publications, such as our books, which we've rolled out here at this conference, the Landsat Legacy book, beautiful book. 2 more books coming out this year that will be really great books, the Manual of Remote Sensing and the new DEM manual, so be looking for that. We have new programs that we're developing, and again, it comes from this revitalization. Our members are stepping up and wanting to do more and work with other agencies, America View and others that are here, that are develop programs that are designed to foster our young people, our students, our early career professionals, and ultimately our future. And we have several new programs that we're rolling out, and you'll be hearing about that are in that category. I would like to invite each and all of you to become members. We need you. It's through your membership dollars that we fund these efforts, and we can't do it without members. So if you're not an ASPRS, I would implore you to become an ASPRS member. And join us in February for our annual conference, which will take place in Denver, Colorado. It will be one of our first co-located events with the International LIDAR and Mapping Forum in Denver, Colorado, February. So I'm now going to have the honor of reintroducing to the stage a woman that we heard from yesterday at the plenary, and she's our moderator for today, Barbara Ryan, who is the Director and Secretariat of the Group on Earth Observations. Barbara.
Thank you very much, Becky. And it's great to see everybody back this morning. Nice full room. So I'm quite excited. We've got a wonderful panel that's going to be up in front of you in a couple minutes. Mike Freilich, Bill Werkheiser, Harry Sakanik, and Vic Leonard. What you'll see is that we're going to switch the order of the speakers a little bit. Harry will go last, so Mike, Bill, and Vic first, and then Harry. So let me just first introduce Mike, who will be our first speaker. Mike's director of the Earth Science Division at NASA headquarters, and you probably all know in the room that it's that program that really's major focus is to, in fact, develop a scientific understanding of the entire Earth system. So it ties in really nicely to what we talked about yesterday. And responses to both anthropogenic and natural changes in the Earth. Mike's got degrees, a nice right up here in your program, but Oregon State, Haverford, and Scripps Institute of Oceanography, and of course a number of medals and honors from the federal government and the American Meteorological Society. But I guess what I would like to say is, I had an opportunity to see a presentation a couple months ago where someone actually showed the signatures on signing the broad open data policy for Landsat, and Mike's was one of those signatures. So I think while USGS had responsibility for the data policy, it's appropriate to give NASA due credit for their role in that data policy change as well. And then also he's exerted just a lot of leadership for CS, the Committee on Earth Observation Satellites. I referenced that in my remarks yesterday. And I personally am appreciative for Mike's leadership because we did have a person by the name of Gary Geller, who was out of JPL, who was seconded to the Geosecretariat to lead all of our biodiversity and ecosystem programs. So Mike, thank you for that, and welcome to the stage.
Perfect.
And I'll give you maybe, is that your first slide?
That's good. Yeah.
And I'll give you maybe 1 or 2 minutes.
Okay. Well, thanks very much. Boy, you can't see anything out in the audience. I'm going to assume that it's packed to the gills. And as Becky said earlier, if you need to leave as I start talking, there's exits here. And thanks, Barb, for the kind introduction. We were happy to second Gary to Geo, and I learned a lot about the bureaucracy during that process, which I otherwise would not have known. The NASA bureaucracy, exactly. Geo was easy compared to that. So today, I just want to give a very brief overview of our NASA Earth Science Division programs and status, hitting basically 3 points probably. One of them is to tell you what we do complementary to and in addition to our work with USGS and many of you in Landsat, because indeed we have quite a large program, of which Landsat is more or less 10%. We'll go over the flight portfolio, that is, using the unique vantage point of space and our satellites very briefly, but with an eye towards at least Mike Freilich's view of how the budget deliberations will play out, and it's a fairly optimistic view that I would like to get across to you. And then spend a little bit of time talking about programmatic innovations. At least they're innovations from the standpoint of the government and how it is that we're interacting with new and different partners in order to bring all of you the measurements that we all need. So fundamentally, as Barb mentioned early on, our objective in the Earth Science Division is, our objectives are twofold. The first one is to understand the Earth as an integrated system, using the unique vantage point of space, but focused on the understanding and the science part of it. Not just the individual processes, but rather the interactions between processes, and it's those interactions which help to define our incredibly complex planet and environment. And from a scientific standpoint, we sort of organize our endeavors into these 6 thematic focus areas that I show here. Each one of them is individually interdisciplinary, and they partially overlap so that we can be sure that no part of the Earth system falls through the cracks, if you will. The second objective that we have is to take the measurements and the understanding and turn them into societal benefit to improve the lives of each and every inhabitant on this planet through the development and the testing of focused information products that link together the understanding and the needs of users. To do this, we basically have 4 elements of activities, starting sort of cyclonically in the upper right. Our flight program utilizes the unique vantage point of space to make measurements of many different quantities, all at the same time, many different scales, because all of the time and space scales on this planet are interlinked, and to provide the measurements that we need. And the flight program is about 60%, a little bit less than that, of our entire overall budget. The research and analysis program is the integrating part, where we redeem the investment in the flight program in order to take the measurements and gain understanding. And the RNA program is run from science, not by missions. So we're not doing analyses of a particular mission's data, but rather we are using all available data from NASA missions, from other domestic agency missions, from international partners, from the commercial sector where available, to answer science questions. I mentioned the applications program earlier. That is the bridge between our understanding from a scientific standpoint and the real questions that users have, and so that our understanding can be used for policy decisions. And the technology program underpins it all so that we're maturing today the technologies that will enable us to make the measurements in the future that will be needed by the science. So to turn to our flight program, this just shows the NASA research satellites. Doesn't show Harry's operational meteorological satellites. It doesn't show our partner, international partner spacecraft. We have the largest research satellite program on Earth. The lower part of this chart, with mission names that are sort of in green and that bluish color, are our on-orbit missions right now. And they're changing actually every day, unfortunately in a slightly negative direction the last couple of days, as both Grace and Katz have given up the ghost after long missions. But we have about 16 or so research missions and major instruments flying right now, making a whole variety of measurements of many different quantities spanning the Earth system. In the upper portion of the chart, are our firm missions that are due for launch. They're under development now and due for launch between basically now. Our next launch is going to be December 4th, the TSIS-1 instrument to the space station, followed by Grace 2 in March or April, and then moving forward between now and 2023. And we have nearly 20 missions in the pipeline right now, funded and under development. And of course, in the upper right-hand portion of the chart there, where it should be at the very pinnacle, is Landsat 9. Okay. And you also see that we are using the space station, and we are also with many instruments on the space station, and we have quite a rich portfolio of technology and science demonstrations using CubeSat form factors. Now, the President's FY18 budget request, which is presently in front of Congress right now, proposed that 5 of the many missions, the nearly 40 missions that are on this chart, be terminated. It's a proposal. You can see what the impact of that proposal is if we go back and forth between the request and the program of record right now. Right now, we are funded for this program of record. Congress is deliberating on whether or not to appropriate money in FY18 for the President's request or for the President's present program of record. And it is my optimistic and personal expectation that we will end up somewhere closer to this, than to this. And I can tell you that Landsat is nowhere near the dividing line, okay? Don't worry about that. It's 10% of our program. We carved it out several years ago, sustainable land imaging, and for the nation's good, for science's good, for the agency's good, it is there and will remain there. And of course, I don't have to go through this chart for you at all. The Sustainable Land Imaging Program is, for the first time, at least in my experience, the first time that we have been able to get together as a set of agencies, as a collaboration between USGS and NASA, with the administration and with strong congressional support, in order to have not a set of episodic NASA investments in Landsat satellites followed by long periods of USGS operation, but rather a sustained multi-mission, multi-decadal plan to ensure that we have sustainable land imaging measurements with technology infusion over several decades. And that's what you can see in the upper right portion of this chart continuing. Again, the NASA investment, and this is in the President's FY18 budget request, so I'm not telling you anything that's embargoed or whatever. The NASA investment over the next many years for sustainable land imaging, including technology investments, is on the order of $175 million per year to ensure that we are maturing technologies, making architecture decisions, and developing future Landsat approaches, not necessarily carbon copy measurements, but a measurement system to provide this information into the future. And finally, if I can just take a couple of more minutes to talk to you about some flight innovations that we have been pursuing for several years, that we continue to pursue, and that are in everybody's budget. Congress's appropriation, the administration's request. We are moving more and more to utilizing constellations. Heterogeneous constellations in the upper right, like the A-Train, where we put together many different missions into a single virtual observatory that's far more capable than any individual satellite could possibly have. Semi-heterogeneous or semi-homogeneous constellations like the Global Precipitation Measurement constellation on the left, where we put together missions from different agencies making similar but not identical measurements, all of which contribute to a better, more rapid sampling and a better understanding globally of key variables, such as, in this case, precipitation. Now, for the first time, we know precipitation over the globe with sort of 30-minute and 10-kilometer kinds of resolution with relatively high accuracy. Before GPM, all we knew was that wherever I was going on vacation, it was going to rain. We are also using every aspect that we can, every leverage, piece of leverage that we can to get measurements up there efficiently. In the center, you can see we're using hosted payloads on geostationary communication birds, both Tempo to launch and Geocarb to launch, and we have a solid program for that, a public-private, call it a partnership, but it's very transactional in this sense. We're using the International Space Station where it makes sense. It's not the perfect platform for observing most of what we're looking for. On the other hand, if I can get 80% of the science for 40% of the cost, because all we have to do is build a bare instrument, they'll launch it for free, they'll hang it on the space station for free, we'll deal with the operations costs. If we can get 80% of the science for 40% of the money, this is my application, by the way, to go into the private sector, we think that's a good deal. And we're working it out well. And we are getting more and more into the homogeneous constellations with small satellite form factors like Cygnus, to use reflected GPS from the sea surface to look at air-sea interactions in the developing eye walls of hurricanes, and the to-be-launched Tropics to make frequent sounding vertical profile measurements of, again, tropical cyclones and hurricanes. The point being that we are not simply doing the NASA missions of the past, but we are working with new partners, and we are infusing not only instrumental technology, but also observing system new technologies continually into the program. And key to all of this, of course, is what Barb talked about yesterday, which is free and open data exchange. We can't bring together many different measurements of many different quantities, which are far more expansive than any single agency or any single nation could provide. We can't bring them all together unless everybody agrees to free and open data exchange. NASA Earth observing data has been available through our data systems, which, by the way, are another 10% of our total ESD budget. And we've been doing that since 1994. And we are happy to work with USGS, as Barb mentioned, for the tremendous free and open exchange for Landsat. And I think with this, I'll probably stop right now. Thanks.
Great, thank you very much, Mike. So what we're going to do is we'll hold off on questions for Mike and actually for all the speakers until the end, and then we'll ask them to come up on stage. So listen, next is going to be Bill Werkheiser, and Bill is acting director of the Geological Survey and has been probably since the change of the administration. Bill joined the USGS in 1986, and I can tell you that Although I'm older than Bill, we essentially grew up in that organization, and we had a nice chat last night about growing up. It was in the Water Resources Division, and so Bill spent much of his career in that division, but in a number of different positions. And then it was the Hurricane Katrina event. He was involved in a natural hazards program, and I would say that also kind of catapulted his career, gave him more visibility, exerted more leadership across all the disciplines of the Geological Survey. Certainly folks in the institution and in the Department of the Interior recognized his management abilities, and so moved into a number of associate director positions, then a deputy director, and then I think that's largely why he was tapped in this administration to be acting director. So Bill, please join us on the stage. Thanks.
Thank you, Barb. And I have to say that I've had the opportunity over the past few days to both visit AROS that's here and listen to the talks, and I heard your talk yesterday, and I was just going to say what Barb said and sit down, and we can move on from there, because that was an excellent talk and was, I think, captured the essence of today also. But as I've attended and I've looked out and interacted with the folks, I was reminded of a story, and the story goes something like this. There's a guy in a balloon, and the winds change and he gets lost. He doesn't know where he is. So he sees someone on the ground and he says, "Excuse me, but can you tell me where I am?" And the person on the ground says, "Well, yes, you're about 40 feet up and you're in a balloon." And the guy in the balloon goes, "Wow." He goes, "You must be a scientist." And he says, "Well, I am, but why do you say that?" And he says, "Well, the information you gave me is 100% accurate and worthless to me." So the person on the ground says, "Wow, okay, that's fair, but you must be a manager." And he says, "Well, I am, but why do you say that?" And he says, "You don't know where you are, you don't know where you're going, and somehow that's all my fault." Right? So the reason I tell that story is that, that kind of describes the tension we have sometimes with being a science provider and a science user, and that the science user and the manager doesn't always know where they are or what they want to do or what the issues are. They have a sense of it, and we as science providers have that responsibility to provide that information to them, even though we don't know exactly what the parameters are. So there's that tension and that interaction that takes place, because if our information is viewed as being 100% accurate and worthless, we're not going to be around very long. So that's why I'm going to step back just a little bit. My topic is the Landsat, but I want to talk about Earth observations in general and the USGS just for a second. Because within USGS, that describes us, Earth observations. That's what we do in large part. So we have ground-based systems, our stream gauges and our seismic networks are kind of examples of that. And then we have our remotely sensed platforms, and Landsat is by far the premier vehicle for our remotely sensed data. And it's hugely important. But we have to stay relevant, and we have to keep our eye on what are the uses of that information, not just that it's great and it's what it's what gets us off, but it's what are the real uses of that, and that's what we have to focus on. And I think the Landsat team has done an excellent job of conveying that to Congress, but we have to keep on that mission. With changing administrations, we had great support in the previous administration. Mike was part of many of those discussions, even down to the Department of the Interior. And we've been pretty effective in the new administration in crossing that boundary between administrations. So this administration gets it also, and Congress certainly gets it. As Mike said, when you're in a budget arena with declining budgets, Landsat is not one of the things that's on the table for declining budgets. In fact, I think it's maybe one of two programs within USGS where for the Landsat portion specifically, they're increasing budgets because of the Landsat 9 launch. So could I just hit this? Okay. So I don't think I have to tell you what Landsat is. It's got the longest history, 44-year plus history, continuous data collection with 2 satellites in the sky, an 8-day repeat, and far more than 2 million images. And the free and open data policy has been a huge boost to us. But I will tell you that that's been coming under threat here recently as budgets decline and as we need more resources to do the work we need. Questions are, is that a viable policy for the future? Can we maintain that free and open data policy? And I think we have good arguments, but we have to continue to make those arguments. As new players come in, they ask those questions, and we'll talk about that in a little bit. And why Landsat? Landsat, as you all know, is kind of the gold standard. That moderate resolution of 30 meters is ideal, or it's near ideal, for detecting and describing landscape change on near the surface. And the fact that it covers every part of the Earth every 8 days is huge. We'd like to have more, I understand that, but it really hits the sweet spot for where we are. And then why interior? You know, that partnership that Mike described between USGS and NASA is huge. It brings together the NASA's flight legacy and satellite legacy, and combines that with Interior's responsibilities for land management and being responsible and stewards for those public lands. So in 1992, under the Land Remote Sensing Act, the USGS, or Department of Interior, was given responsibility under USC Code Title 51, Section 601. You know, when I was in college, if you told me I would have to know what these things meant, I would have said, I'll do something else. But now I do. So, and we're responsible for the archive. And I had the opportunity 2 days ago, I guess it was, to visit the archive at AROS, both the physical and digital archive, and it is incredibly impressive, the operation that goes on there and the care that these folks take in doing that archive and retrieving that information. It's incredible. And you know, the critical word there is active. That's an active archive, so that information is available for all users. And I think right now it's like 250,000 registered users for the archive, which points to its value to people. And you've seen this before, and just kind of describes that partnership between NASA and USGS. Goes back into the 70s and has evolved from that time. NOAA's in there also, and our evolving mission and our evolving responsibility for now doing also the ground station work and the flight ops. And Mike already mentioned this, the private-public partnership, and that's huge. You know, people, especially as a new administration comes in, they say, why is this a governmental activity? And we make pains to educate them that, you know, this is truly a public-private partnership. We have many public collaborators in the NGO arena, the other agencies, but also a significant private partnership with getting the information launched, flying the satellites. So it is a true public-private partnership. And as we go into Landsat 10 planning in the next year or so, that's going to come under increased scrutiny and interest. There is a big interest in exploring what exactly that partnership should look like into the future. And we've seen this, and Barb, your slide, you said was going to be 46 million, but it was actually 70 million. I thought it was 70 million. This actually says 46 million. I don't know. I think it's a matter of the updating of when the slide was updated. It is 70 million scenes. And the reason you've seen this many times before also, the reason I point to this is that this is a graphic we use oftentimes to show the value of Landsat and how widely used it is. But it's not the reason, it's not the value, it's a surrogate for the value. And as we go forward in time and as we go into a cloud environment and cloud computing, these numbers are likely to go down because once you're in the cloud environment, you're not doing those downloads, so we have to look at what's the true value. And the other thing, I'll say let me back up and say, 2 years ago, I knew nothing about Landsat. I was in charge of the water programs, and for me, Landsat was that big sucking sound over there, taking all my money to do other things. But I've become a convert, and I see the value, and I've gone from seeing that I've got our missions in USGS, whether it's hazards, water, mapping, ecosystems, and Landsat. I went from that to seeing Landsat as foundational to everything else we do. And that's the message we have to convey, not just for the USGS, but for society in general. And I'll talk about that a little bit more, but we have to get at the true value because when I did my first briefing with the new administration, the person who I was briefing happened to be an economist. And we talked about, having this great, since we've gone to this open and free data policy, the explosion of downloads. And he said, well, of course. I go, what do you mean, of course? He said, well, there's an infinite demand for a free product. And he says, that doesn't tell me how it's being used. So I think, well, then fortunately I had the Landsat folks there to get at what the real uses of that information are. And I think for the future, that's what we have to concentrate on, or what are the true uses, what are the true benefits. And I think that maybe the next slide gets that. Yeah, so and so when we look at the value, we, I think your slide had 1.7. We used in inflation, we put 1.8. And so a value of $1.8 billion per year. And the key part of that is, and Barb mentioned it yesterday, is if we did not have that free and open data policy, what would that value truly be? When we were distributing 20,000 scenes a year rather than, what are we up to now, 20 million scenes for 17, I think. How does that value decrease if you have to charge for the data? And that's a real value to the economy, to large portions of our society, and that's a message that gets through to new administrations, and they get that. So I think that's what we have to keep our eye on. And you can see some of the annual savings for some of the 16 key applications, and this is all work done out of the, I think it's the Landsat team, Landsat Advisory Committee. So I think you know that Landsat 7 is nearing the end of its life. It's running out of fuel. We're having some issues with the instrumentation on board. So in order to maintain that 8-day repeat, we need to get another satellite up in the air as quickly as we can. The projections right now, I think, are by 2020, Landsat 7 will probably cease being operational at that point. And is that right? 21, okay. You told me 2020 when you're trying to get the money, but so 2021. And so we have to have another satellite in the air. And the original planning for Landsat 9 was a 2023 launch, and that's been moved up because of the life cycle of Landsat 7, which has been in the sky far longer than its operational expectancy was. So there have been numerous improvements. I think Landsat 8 has come across as a huge success. The launch and then the handover to USGS for flight ops was as seamless as I could think of. At least that's what you were told me. I don't know if it's true or not, but I heard it was seamless. Mike says it's seamless. Okay, it was seamless. So it's been extremely successful with some of the improvements, and you can see them sitting there. I know in the water community, which I'm most familiar with, the thermal imager was just a huge boom to that community, and there are other communities out there that had seen similar enhancements. So now we're on the road to Landsat 9, and there's also been discussions of, okay, what if we went back to a 2023 launch and had and could spread that budget out so it's not such a big budget hit in 1 year. And the argument we've made, and I think we've been successful, is that planning is too far along down the road. Contracts have been let, that ball is gone, that train has left the station. So we need to have that 2020 launch, and I think we've been successful in delivering that message. Although every time this administration has been a little slow in putting its political appointees in place. Every time there's a new political appointee, we go through the educational process. But I think we're over the hump there. I think where there's enough momentum and enough knowledge, at least within the interior, that I don't think we're having that issue anymore. Right. So, and we're with you, Mike. In fact, our part of the budget is so small that if NASA would like to fund us for the rest of it, we'd be happy to take them the money. So, no, we are committed, and every year when we look at our budget priorities, at least since I've been involved in budgeting for the past 7 or 8 years, if we look at our top 5 priorities, Landsat and Landsat operations, Landsat launch has always been within the top 3 of those priorities, and will continue to remain there. And Landsat and commercialization, as we look to the future, and we looked as technology evolves, Landsat 9, as you know, was a kind of a carbon copy of Landsat 8. And as we look to Landsat 10, I think everything's on the table. We want to have the most efficient satellite system that delivers the information that this country needs, that the society needs, and that our partners need. So we're committed to that planning and moving forward with it. And I think we already talked about that. And I think I'll end there. Okay, thank you. Thank you.
Well, thanks, Bill. Very much appreciated. Let's see, our next speaker is going to be Vic Leonard. So we'll, oops, not that one. Get your, oh, Vic, you've got a PDF here that you're going to speak from. And I'll let you figure out how you're going to do that, okay? Vic's senior fellow at Digital Globe and more than 4 decades in research and development. And if you look at his bio, not only does he have experience in the private sector, his current position, but he's held operational positions with the U.S. Air Force, the CIA, and then, of course, a number of private sector entities. And so I think it's really nice having you on the panel, Vic, because we'll have heard from Mike at NASA, Bill at USGS, Harry after you, but it's great to have a private sector entity here, so welcome.
You know, one of the funny things that happens when you're like third or fourth in line is that you get to think about all the things you might have put in slides, and people say things that kind of either really excite you or make you really profoundly depressed. So I was the president and CEO of Resource 21, which would have built LDCM and 10-meter resolution, so forth. And for a variety of reasons, people have to make decisions, but that didn't happen. I went to Digital Globe instead. I'm over that. No, really, I'm over it, okay? All right. So actually, it's good to have a mixed career where you bounce around and do different things, whether you're forced to do it or not. And along the way, you learn things. You say, oh, you know what? When we were doing that last time, this is how we solved that problem. And so you kind of learn things and you take them with you. So everything I did in support of LDCM actually ended up being folded into some of the spectacular things that we're doing in the commercial industry today. And I'm going to show you a little bit of that in the briefing. But my briefing is bigger than Digital Globe. It's really about not only what we can do with our 5 high-performance satellites, but a revolution that's happening right now because of essentially the cost dynamics and miniaturization and things like that. And by the way, you know, our satellites are in fact cost centers for us. So we also like to get the cost down. So we are in fact embracing all those technologies and actually all the different modalities and the different sizes and scales of these things, because they allow us to solve yet a different class of problems that the science satellites often don't. But the really cool thing is that we can't get along without data that comes from those science missions. And I'm going to show you that and spend most of my time on one diagram, which gives you a sense of where everything is going. Well, actually, I can see them here. This is good because I normally have to get out and walk around to see what it is I'm briefing. So there is a vision that Digital Globe has, and that's to see a better world. And we take that very literally. We spent most of our time on the bottom half of the diagram for the last 25 years that we've been involved. Somewhere along the way, actually a lot of the people who came in from the LDCM organizations kind of said, yeah, but we really got to think about what's happening in terms of population and all the things that involve sustainability, which affect a lot of the nations around the world in a very, very serious way. And it involves a scale and a revisit and a quality that's science grade. It's absolutely science grade, and so that has been a big push for us in modern times. And often people talk about Landsat and doing agriculture and those kinds of things. It turns out that if you want to have a good sense of what's happening in one area and not so much in the other area and do logistics, it's kind of okay at those kinds of scales. The quality is good, it's just it needs to be finer scale, and it needs to be a little more frequent. If you want to do active management, which is a hallmark of sustainability, you don't want to put any more fertilizer on then you absolutely need to use in a particular part of the field. And that becomes a scale kind of a problem. That doesn't mean that Landsat can't play, but it means you have to do some other things, and I'll show you an example of that later on in the briefing. But active management means it's a really, really big information problem, and it takes lots of different modalities and sources of data. I'm going to jump ahead real quick and say this is where I'm going to spend all my time. It's about all these different modalities and how all the systems, including the science birds, fit into this. But I'm going to back up and talk about we are broadening in a very fast way in the commercial world to essentially ISR. We have services that will take the imagery and run it all the way out to the information that's actionable that you can use for planning and whatever else you're trying to do. But what we're finding is that the kind of missions we tend to do right now falls in the category of things that work for both private, or not both, but private and military and intel and civil science mission needs. And basically, there's a lot of overlap between what we can do and how we can help national security organizations, but I think we can also help civil and science. And so I'll make that point in a couple charts. The real thing is that we're being driven by certain kinds of missions to extremely fast, very near real-time capabilities and day-night and all-weather. And it's electro-optics, it's SAR, it's RF, and other modalities. And we have to get it there very rapidly and very securely. And there are many operational challenges that kind of go with the short time constants. But in general, in order to solve some of these problems, we have to go to a model which is very hierarchical. We actually need all these different modalities because in many cases we're talking about very broad areas that have to be analyzed and monitored and so forth, and then tipped to forensic quality kinds of capabilities. And so we have found over the years that the best solutions do in fact rely on actually orchestration, where in my definition, the orchestration problem is kind of a simple view that each of the modalities, each of the different systems actually have their primary missions, and then there's some places where they could help you with yours. And if you can find a way to very rapidly iterate between kind of a bartering and bidding kind of a mode, then you can actually get to a point where they don't have to be fully integrated. They just have to be able to show up often enough to actually help with the problems you're trying to work. And that's kind of a real change that we're seeing. Now, back in 2015, in I believe it was July, the Associated Press was trying to crack the code on a slave labor and seafood industry and illegal fishing, IUU, and all that kind of stuff. And they asked us to help out, and we used Worldview 3, and we were pointed at Nader, did a big search box over an area suspected to have an illegal transshipment going on. The boat in the center here is the Silver Sea 2. The two other boats were slave ships. They had people on them who had not been home in 30 years. They were basically kidnapped and taken to sea, and they were part of illegal fishing. And we were able to actually forensically determine this. I'm going to jump, I think, ahead real quick to, and by the way, there's a lot of slides in here which I'm leaving to be part of the materials at the end, so I'm not going to talk every one of them. But here you can see the forensic quality of Worldview 3. It's basically, this is like, I think, 33 centimeters, I suppose. So it's about a foot. You can definitely conclusively say that is the Silver Sea 2. And you can also see the hatches that are open and so on and so forth. So they moved in, they caught them, they threw the crew of the Silver Sea into jail. They took the boat and impounded it. And it was very, very encouraging for those of us in the industry to say, aha, we did something that makes some good. But there's also those of us who said, oh man, but you understand that the adversaries aren't all idiots. They are going to adapt. And when they adapt, what are they going to do? I don't know. How about do the transshipment at night or in the middle or early morning when we're not flying in our 10:30 a.m. sun-sink polar orbit? And so we already knew that was going to come, but we didn't realize the whole magnitude of that. But it's been kind of a real interesting rocket ride to kind of deal with that. So I'm going to talk now about this $23 billion illegal, unreported, unregulated fishing problem. That's a global problem, and it takes ISR to kind of solve the problem. It takes tipping and queuing. Along the top, you notice the idea. I've got some numbers, 1, 2, 3, 4, 5, and the first thing is really simple, is there's something going on. 2 is to locate where it is. 3 is to basically identify what class it is. 4 is to say, what's it doing? How fast is it going? Is it actually in the act of fishing, for example? The final one, 5, is not something I'm imagining commercial entities do. We're not going to literally go grab boats or illegally, you know. Maybe 40 years from now, there'll be bounty hunters that go off and do that, but it won't be us in the remote sensing business. Around this whole diagram, you see several different things, and this is where I'm going to talk about the kind of radical shift we're seeing in all of the space stuff for commercial companies. So I mentioned the day-night thing. We really need to have day-night all-weather, and we also need to be able to, basically with electro-optics, do forensic things sometime, anytime during the daylight hours. As it turns out, just looking at Digital Globe, when we get to the 2020 timeframe, the replacements for 3 of our birds that are aging out are our new class of birds we call Worldview Legion, and they are designed to, in conjunction with the other higher performance birds, be able to revisit a particular spot at certain latitudes every 20 minutes. So you can basically make measurements of activities that are going on. Whether it happens to be, by the way, we're very big at humanitarian assistance, disaster recovery. We spring into action immediately. That data is shared freely and widely. And by the way, the data from the next few license says we can let state and local governments use the data. We're happy to have them do that with the U.S. government supports that. It works the same way for friendly foreign governments. We share the data. The only proviso is that it doesn't somehow fundamentally allow some other entity to build a business which undercuts the other private markets. And that has worked remarkably well. There hasn't been much of any kind of a challenge. But the thing that's kind of interesting is that what always happens when we have these technological revolutions, and I think the one for much cheaper space and miniaturization is kind of the latest one, is that people start thinking, well, man, now I can get rid of everything. Probably could get rid of Landsat, just have some CubeSats. And the answer is, no, that's not the way it works. And so we're much wiser about how we do that, and we see all of it. So I'm gonna give you a sense of how big the problem is with illegal fishing in terms of a technical problem. There are 14 ways that I'm aware of to actually do IUU crimes. And almost very few of them are open to, by themselves, just imaging or something that will tell you they're actually guilty. And the only way to do it sometimes is to actually have other information. So on the lower left of the slide, you notice there's open source things. You have to have a permit to be operating your vehicle, your boat, in a certain part of the ocean, inside of someone's exclusive economic zone. And that permit has to agree with what day of the year it is you're actually doing it and what fish you're actually going after and so forth. So you might be able to see whether or not somebody is actually engaged in fishing, but you still have to understand what is the actual boat? Who is it really that's got it? Because how do you know, especially if they go dark and they turn off their AIS? Same old with, you know, so we found ways to deal with this thing. And at Digital Globe, for the past 20 years, we've had a Marine Information Services group. That's the one on the lower right. And they use a lot of the science data that you are all talking about, have talked about so far today, to actually do things like what are the sea temperatures, plankton concentrations, things like that. And just imagine for the scenario here, I'm gonna move the mouse. Is that cursor showing up? Kind of, sort of, okay. See this little sliver down here? I'm just imagining that is in fact an area that it's one of the predicts that comes out of our service that says, this is where the fish probably are. So John Dillinger was killed on the same day he gave an interview where someone asked him, why do you rob banks? And he says, because that's where they keep the money. So the way you crack a lot of these problems of where you cue people is to be very smart by using everything at your disposal, and the full complement of all of these satellites, the ones that form the science backbone as well as these other modalities, are part of it. And without going into more details, happy to answer questions offline about that thing. But that's kind of what's exciting about this. We are going into radio frequency things which are both externals and internals, AIS and other kinds of things. That helps us to even finger and resolve which boats are actually out there when there are sister ships that all look at the same in the other domain. The thing that's probably remarkably different with our commercial satellites is they have a lot of agility, and in some cases extreme agility compared to a lot of the science payloads with their extremely wide field of view but bigger pixels. And we have found that for the kinds of markets we play in mostly, the world is not that uniformly interesting. So we don't have the kind of staring at nadir kinds of things, with the exception of, to the right, things like planets, little doves and so forth. But that doesn't mean they're not good and useful. It just means that we have to do other kinds of things with our satellites. In fact, the trades that we make in the missions we're looking to in the future include our information problems are against all of these modalities and all these different parts of the spectrum. One of the satellites, Worldview 3, is a superspectral instrument. It's in the V-near and the SWIR, and it's collinear and it's coincident, and it has a 30-centimeter panchromatic, and with a sharpening, you get spectacular information extractions with that. We don't have to use that all the time. We don't need it all the time. Maybe the thing that reinforces the idea of the science thing, which I talked about a minute ago, is the fact that we knew when we started to do some of these problems that we had to get to extreme surface reflectance kinds of numbers. So we built something called DJA-comp, and it's twice as accurate as flash, and it's as fast as QUAC to use. And it used every particular pixel gets a custom solution, and it's on the order of at 10%, 10% reflectance, it's on the order of 0.5 to 1% accurate. So it turns out when it comes to solving lots of problems, it's just amazing and essential to what we're doing. So we learned our lessons in the community that most of you are working in about the importance of the science-grade data. The next kind of comments I'm going to make, and then I'm almost done here, but the 5 birds that Digital have right now are the ones you see on the right up here. They're very spatially accurate. They have very fine resolutions. The first Worldview 1 and GeoEye 1 and Worldview 2 are going to be replaced by these Legions. They will be 30 centimeter as well, for the most part. But what's really kind of more important is that we have built a platform. And right now our total archive from the last, 1999 to 17, so it's about 18 years, is about 100 petabytes. We've got most of that now. We've pushed most of that into the cloud. And we have built an ecosystem around that whole cloud. We have our data, we have Landsat data, we've got RadarSat data that all can be hosted in that. We have our own apps and tools which we provide as part of a service. We allow people to come in with their own special algorithms, and here's the fundamental difference. In the old days, when you wanted to go buy a filet mignon in our meat market, we said, well, we sell whole cows and we sell half cows. What do you want? And you said, oh, what am I going to do with the whole cow and the leather and all that kind of stuff? And by the way, said, you have to pay for the whole cow, by the way. Well, we're changing that model to where people can come in, whoever they are, scientists, whatever, with limited budgets, and they can just rent the data for the period of time they need it and run their engines, run our engines, get the results out, export those things to something else, and away they go. So this is our way of really jump-starting a massive application ecosystem for everybody who wants to do it. And there is no free anything, but if you have a sponsor who is willing to support Landsat being built, if the same kind of sponsor is willing to say, well, let's just pay a certain amount of money for access to this massive platform, then that will maybe help your whole science mission in a way that the other modalities cannot. So just the last couple things, people always wonder, well, why don't you just use the smaller satellites, and maybe you shouldn't. But here it was 35 centimeters, so that's that same boat turned sideways. You can see a lot of the details available. At 1 meter, it kind of fuzzes out, probably still forensic. 2 meters, well, there's a length, you can get out of it. There might be AIS. If they have AIS turned off, you don't know. When you get to 3 meter, the first reaction for people from the high-res community is, man, that's just garbage. My reaction is, no, actually, that shows some sort of a transshipment going on. It actually shows it is transshipment, because if it were a refueling operation out at sea, the little blobs would be further out and there would be these lines refueling them. So it's some information, it can be done with doves. So right now the doves are planning, to be in a certain orbit regime. There's no reason why they couldn't be more with other modalities, and same for lots of other things. Tipping and queuing, You know, it's one thing to do forensic mapping to begin with. It's another thing to wait for, in this case, some blobs to show up at 1 meter or 2 meters, and then just come back and then use your high performance satellite to go in and say, I know exactly which every one of those vehicles are. The problem of maintaining custody on things is you've got to crack the problem of 3D dimensional, 4D dimensional objects and databases and be able to correlate those things over time. And that's going to be one of those tough problems. The last one I'm going to talk about is just simply when it comes to figuring out which captain and crew are guilty. You can see there's a number of boats in here where they look kind of the same, except for maybe there's a trunk in a different place. There might be big rust spots and everything. That may be enough to say we know which crew is out there doing that, so now you can bring them to court. But it also might not be enough, in which case the only way you tackle that is by using signals of phones running back and forth, and when the same basic shape of the signals without knowing who's making the phone calls, when that hasn't changed for each of the boats except for one that had these other kind of signatures is gone. Now you know who did it. So it gets to be a really interesting policy question and a legal question, and you have to have the right modalities to actually pull this off. But that's the kind of class of things that we're doing with commercial and private stuff today. And one last comment about Landsat. So here is an image of Colorado, and at 30 meters, you kind of say, well, maybe there's some pine beetle up in the upper left and so forth. At 6 meters, like you'd have with the rapid eye, for example, well, maybe it's more isolated. Get down to 2 meters, which it is certainly within the regime of the skybox kinds of birds and planet. Now you're starting to say, no, it's really, that was just open dirt, soil. But you're starting to see in this area right up here that maybe that's the tree. So maybe one way to deal with pine beetles is to use these kinds of things to go find spots. The other problem, though, I want to show is that here's the difference between 30 meters and for small holders using 6 meters, and even 2 meters, and even 1 meter. Now, you might say, oh, he's bashing Landsat. I'm not. I'm really not. In fact, if you can take the kinds of models we can build that are largely persistent, then when you get to an area like this where it was just luck that the 3 meter pixels were lined up this way between in that one Landsat image, you might say, well, how does that help me? Holy cow, I mean, they're never going to be in the same place. And the answer is you can actually use that other information to actually figure out what's outside the box that's persistent that you can remove from that pixel. And now all of a sudden you've sharpened the emission utility of 30 meter pixels. So that's pretty cool. I wanted to just cover the atmospherics is a big deal, but typically, and I promise I'm almost done. So typically you have, with 30% clouds, you have 30% shadow, and then 40% is good pixels. And it turns out if you don't get to surface reflectance, then you have to kind of throw away or do something weird with the cloudy stuff. And in our case, our atmospheric compensation allows us to use that stuff. So it's like having more satellites in terms of revisit. And we did some work up in Iowa a few years back to kind of prove that gets us really good information very quickly. One quick, here's an example of the atmospheric correction removing haze. Worldly 3, we can see the stuff on the ground. I mean, I would love to see NASA take on actually mid-wave IR mapping like 3 orbit planes throughout the day as a new service, because literally be very, very powerful to use that for lots of civil applications. And I'm going to stop right there in the interest of time, but you're welcome to take a look at those afterwards.
Vic, thank you very much. That's great in terms of integration of a number of different sources. Harry, I'm going to ask you to come up because you've got to do a switch on computers, I think. So last speaker of the panel is going to be Harry Sakanik, and Harry's director of STAR, which is NOAA's Center for Satellite Applications and Research. And then also, I think if you look at his bio, he was the first director of the NOAA JPSS, so the Joint Polar Satellite System, and I think you guys have had Had a launch, I was gonna say.
We had 2 launch
Just-
attempts in
it's-
the last 2 days.
And you're in a holding pattern?
Yeah,
Okay.
upper atmospheric winds.
All right. And then also, while he works for NOAA now, used to spent some time in NASA as an aerospace engineer. And then, while in my early career, I didn't know Harry, but I have had an opportunity to meet him over the last couple of years, because he's also working on one of IAF's. We've got a GEOS subcommittee in IAF, and Harry's been helping out on that. So Harry will turn it over to you. Move this whole thing.
I think I'll be,
Okay.
Hey, Barb, thanks for the introduction. Happy to be here. So I want to spend a little bit of time going through a couple things, but the most important thing that I want to talk about is state of Earth observations in an operational agency from our perspective in NOAA, and also talk to you about where we think we're headed, where we've been, and give you some examples of the state of the observations. So first off, I'll start off with our fleet. We have a number of missions on orbit right now. We've had satellite observations on orbit in general since the April of 1960 when we started our first polar satellite, and it was actually before NOAA was formed as an agency. We've had a long history then of Earth observations for operational purposes, supporting weather and overall environmental missions. Our latest additions to the fleet start off with the GOES series. So we just launched last year the first copy of our new series of geostationary operational environmental satellites. Tremendous increase in capabilities over our earlier satellites. Many multiples of capability in terms of resolution and spectral bands and other features like that give us tremendous power to resolve what's going on real time in the atmosphere as well as on the oceans and on land. And so one of the big challenges we get in the future is to really work hard on improving applications. I think we're at the precipice of a lot of new advances based on some of the tremendous new capabilities that are out there, particularly for continuous observation for real-time operational needs. We also have been doing new series with polar satellites. The first of these was actually a partnership between NASA and NOAA, the Suomi MPP mission. It was launched in September of 2011. has 5 instruments on it that do a variety of observations. But the most important things that they do are the soundings, vertical temperature and moisture profiles that feed the weather forecast models that are particularly critical for accurate forecasts out to 7 to 8 days ahead. But they have many, many other applications as well. And I'm just going to give you a little example of that in a little bit. Our second, that one's been, of course, on orbit for over 5 years now. It went into routine operations as an operational system for us back in 2014. And the next in the series, JPSS-1, sitting on the launch pad right now. I was down in California right before coming here for the launch attempt on early Tuesday morning. And we had another attempt early this morning. Upper atmospheric winds were too high for the launch vehicle, so we delayed. They haven't set a new official date yet, but I expect it might be in the next couple days. But it's in great shape, and we're really looking forward to that one getting on orbit. What that'll do ultimately is with the geostationary satellites, the GOES-R series, starting with GOES-16, and we have GOES-17 that'll be launching in March of 2018. What we'll have is systems that'll look at the east and the west of the U.S. Then we'll have a third that will be up as a backup, and that's our normal operational constellation. We're also building a fourth one that we have the possibility of using. That'll extend geostationary observations out to the late 2030s with the polar system. We have planned right now JPSS, Joint Polar Satellite System birds, all the way out through the late 2030s as well. So we have a 2 that's in build right now that'll launch in 2021, and then we have a 3 and 4, and they'll launch basically on 5-year centers. And in the polar constellation, what we do is operate 2 birds in the same orbit on opposite sides of the 1:30 in the afternoon orbit. So when JPSS-1 gets up there, it in tandem with Suomi NPP will basically complete our operational configuration for the new generation of polar satellites. The polar system is really interesting also because not only do we need the 1:30 in the afternoon orbit, but we also need the 10:30 in the morning orbit. So we do that with our very close partnership with EUMETSAT, and they fly operational polar satellites in a 10:30 a.m. orbit. And so the 2 of us have an agreement called the Joint Polar System, so we continuously feed data from those polar satellites, basically for use for anybody, but particularly for all the operational meteorology agencies around the world, use those on a continuous basis. In addition to that, we've got some new things that are coming into routine operations. Had a lot of success with what we call COSMIC, which is radio occultation. So there's a COSMIC 2 program that's in partnership with Taiwan and several others, where we'll have an operational radio occultation constellation. EUMETSAT also flies radio occultation sensors. And then we also have the Discover mission, which was launched last year. And it provides solar observations and sits out at L1 as a sentinel for space weather. And of course, that affects the Earth's environment in very important ways as well. So that's the whole NOAA observing system. So when you look at that in a constellation configuration, that gives you a good view of what we have. The thing that I want to mention about this that's really important is that we have had those observations continuously starting back in the 1960s. And with our new generation systems that we just put on orbit and with the new types of observations that we plan on making operational long term, we have current plans in place that are funded and well supported all the way out to the late 2030s. And one of the things that I also want to mention about this is that we make this data free and open. Several of our other speakers talked about the importance of that. That is absolutely critical to how we operate. No way that any one country can provide the observations that are really needed to drive the level of forecast skill that's demanded, particularly of weather agencies these days. So we take advantage of a whole global observing system, not just our own system. So no matter how great it is, we need to add to that observations from the other systems that are out there. In addition to that, NOAA also has many, many other types of both land and ocean-based and as well as airborne-based observatories of various types, including seagoing platforms and that complement the data that we get from the satellites. And in addition to that, they also help make the satellites better through use as in situ calibration and validation sources of data. So we take advantage of those as well. Now what I'm going to do is show you just some examples of the advances that these new systems represent. On the left-hand side there's an image from the new GOES-16 of some storms that were from the spring that went across the central section of the country. I think there were like 13 deaths attributed to these and a large amount of damage across the various areas that the storm had. The other image that I have on the right-hand side is a new type of observation that we have on the GOES-R series, which is a lightning mapping imager. And what that does is will give the meteorologists the opportunity to track very closely where the activity is in the convective weather systems that generate the lightning events. So I think it'll be a huge benefit to them as they start to work with it and begin to learn how to effectively utilize it operationally. So all the GOES-R series will have those on them. One of the other things that's really important about the GOES-R series is its temporal resolution. We have a super rapid capability that gives, I think it's like five-second images. So you can actually see dynamics in the storms that we've never been able to observe before. So it's going to be a very large payoff, both to the operational forecasters as well as science to understand formation generation, how to predict, how to provide warnings and so forth for the challenges that these storms represent. In addition to that, our new satellite series have additional bands, greater resolution. And so now we can do things like real-time help fire incident meteorologists, support agencies that deal with wildfires and other phenomena like that. We can also track fire fronts, get fire radiative intensity and be able to make better smoke predictions for how the plumes are going to traverse downwind of the fire events. So that aids in things like pollution forecasts and warnings. Now I want to talk a little bit about ocean applications. What I've got here is just one example of a product that we call Coral Reef Watch. And so what it does is take several measurements and combine them together to give indications of where the conditions are ripe for coral bleaching events. So that's a very actively used product in the marine community. That's just one example of the things that you can do with the new operational systems that we have. So I talked about the constellation that NOAA has, and I also talked about how beneficial it is to have additional observing systems. You take a look at this, you get a sense of how rich the global observing system is. I think with all the data that we have available now and the capabilities of the satellites that the many governments around the world are operating, both for operational purposes and for research purposes, we've got a huge opportunity to really advance how we serve users. I think with the right types of measures that we can take, we're on the cusp of making some very pivotal changes in how we do business, and also maybe even very transformational changes in how we do business. It all depends on how a number of factors play out over the next few years, but I'm going to talk a little bit about some of those shortly. But the key thing I want to emphasize on this is it takes a lot of partnerships to make all this work well and effectively. Fortunately, in the weather business, weather bureaus started partnering and sharing data free and openly, I think over 100 years ago. And it's been a huge benefit that that fundamental practice carried over into the age of satellites. And with that, we've been able to do things that it wouldn't be possible to do if you were only limited to the sources of data in your own constellation. It's very, very important. So now, with all these operational capabilities, what we can start doing is looking at having whole observing constellations like a geostationary belt. Very soon, within the next few years, we'll have similar capability sensors to what are on GOES 16 surrounding the whole Earth. In addition to the fantastic imagery they provide, they also have gotten much, much better in resolution, radiometric accuracy, and so forth. So now we can start using these geostationary operational and sensors not only for their imagery, but in addition to that, we can use them quantitatively, feed models and other things like that. The other thing that we can also do that's really great, and we've started doing, is to actually blend them with LEO-type observations so that you can get a much more effective data product for the operational user than you ever could in the past when you send them individual products from individual mission series and individual sensors. So where we got to go in the future is to start combining these things together to really extract the optimum, maximum information content out of these. And we've got to give information aid type decision products to people like operational forecasters. Example I always like to give is one that is prominent right now is we have a lot of different types of measurements of sea surface temperature from various satellite platforms. And right now, basically what we do is we feed the operational personnel with maybe 10 different flavors of them from 10 different platforms and expect them to have to choose from those and remember all the different specifics about them in a short-term application where they've got to turn whatever they're doing around in a short period of time. What we need to do is to be able to blend, fuse, and combine those together into the best representation at any location around the Earth at any time, and that's the kind of direction that we got to head in. So we're really in the era of big data. This is just a comparison of what the old generation of operational meteorological satellite series had in terms of data volume versus what it looks like today. So it's many orders of magnitude increase. So we've got to move towards taking advantage of the new technologies and new tools that are out there and bringing them into how we do business. And one thing that I also want to do is look at the motivation for pushing the skill that we provide, the support we provide for the operational forecaster skill. So this is an image taken, of course, earlier in the hurricane season where we had 3 hurricanes lined up, and it just goes back and reminds us of why it's really important to keep improving how we do business. And this chart just shows a montage of all the weather billion-dollar disasters that we've had just in the U.S. this past year. So we really need to work hard to improve what we do so that the forecasters can up their game in terms of skill, regardless of whether we think the number and frequency and intensity of these storms are going to increase. The one thing that for sure is increasing is population and infrastructure, so the need for this keeps growing all the time. So I listed a few things that we've got to think about and address as we move forward, and they include science and modeling, improving understanding of how the Earth system works, getting increased resolution in the models, better physics in the models, starting to couple atmosphere, land, and oceans. All those are trends that are starting to occur in the observing system world. We've got to keep ahead of those, and we've got to keep feeding better data into the models and better data to the operational forecasters. They need integration of the products, like I talked about a little while ago. We can't flood them with a lot of different types of things. What we need to do is to combine them into higher level information. Big Earth data. There's a lot we've got to do to work on advanced methods for processing, distribution, archive, easy access, and security. Data always has to be there, always has to be good, so security is very, very important and a big challenge for us. Technologies. They offer a lot of opportunities, potentially a lot of disruptions to how we do business and what we do, but we've got to work on them and bring them into how we do business. Business models themselves. as you've seen on this panel, there's a government world and there's a commercial world. What we do and what we look at is really providing backbone observations to support our mission and the missions of our partners and other U.S. government agencies and other like agencies around the world. But we also are chartered and have been funded by Congress to start looking at how to use certain commercial satellite data sources that are starting to emerge and potentially become available for use. So there's a lot of challenges with that. Not only how do you make sure that you understand the quality of observations and have commercially purchased observations that can meet the requirements of our users, but in addition to that, how do you work the actual business model and use them to supplement and improve on what we're doing. So we're trying to work through all those challenges now. And then, of course, there's the new technologies and satellites and launch. I think there's a lot of potential for some very, very dramatic changes in the coming years with all the launch service provider capabilities that are looking to come online, and of course with the new satellite technologies that are out there like the CubeSats and so forth. So we in NESDIS are off working on new architectures because it's now the time to do so. We just got our current new systems starting to get into the operational mode, and they last through the 2030s, but given how long it takes and how difficult it is to bring the new generation online, it's time to start working for the things that will come beyond GOES-R and JPSS and so forth. So what we're doing is grappling with all these questions and all these challenges to chart our path forward for the future. What we really want to do in the end is master the future. So I see the state of Earth observations as just being tremendous right now, but there's a huge amount of things going on in the environment, not only the Earth's environment, but in the business environment and the government environment that will probably make this an extremely pivotal time for us, and possibly a very transformational time. I see a lot of change coming in the next 5 years. Thank you.
Thanks, Harry, and stay up, and I would ask the other panelists to come up on stage, and maybe we could turn on the lights, because I do think there'll be a couple questions for the panelists. So come on up, Bill and Vic and Mike. And actually, I wonder, Harry, that was a good last slide. Yes, I wonder if we can go back on that slide. So I guess a couple things. If, boy, it is hard to see, so I wonder if we can turn on the lights so that the speakers can see who's asking questions from the audience. And then I just have one real quick one. Harry, on your last presentation, when you showed the images of the forest fires and the lightning strikes, were those were from a geostationary yes. Satellite? Okay, so every 15 minutes, boom, boom, boom. Yep. Right, okay. All right, questions from the audience for any of our speakers? Jeez. No, okay, great. And if you could just introduce yourself too. All right, so it sounds like that might actually go to Mike and Bill first, but Vic, I think you also referenced that with some early experience. So anybody, Mike, you want to start? Oh, sorry. Question about why is there still ongoing discussion about commercializing the Landsat program? We dealt with that back in the 80s, and it was a failed attempt, and how come we're still talking about it? Essentially, that's the question. I want to make sure I characterized it correctly.
Okay,
Bill.
I'll start in. I think it's primarily a political discussion. The folks who are here now, can you hear me on this? So the folks that are here now were not here when we tried the commercialization. And they point to things, just because the environment was that then, it's probably different now. And so and especially with Landsat 10 in particular, where, it's a whole new world as far as we're concerned. So all options are on the table. This administration in particular has interest in that. So it's a discussion, but I think we have had lessons learned that we can use in that discussion.
Mike or Vic, anything to add?
Yeah, I would just warn against using jargon or code phrases like, commercialization and the Landsat program. We have, as a matter of national policy right now, the Sustainable Land Imaging Program within the federal government. We have partnerships with international partners, providers, like the Copernicus system from the EU. We are developing partnerships with private sector entities. The focus should be on what information is needed by the vast communities of users, and how will we as a species get that information to decision makers in ways that they can optimally or efficiently use it. So let's not go back to the same catchphrases that were used in the past, and let's look at what the initiatives and capabilities really are for obtaining the information and getting it out.
Do it whatever way makes sense. And, in the commercial world, we have plenty of other things to do. If you want a solution from us as a proposal, we'll do it. But we won't freak out if you say no this time.
Okay, Tom, the signal that we got to get to coffee break pretty soon. One more question, though, for any of the speakers, because I think, quite honestly, all of them presented fairly optimistic view of the future, reliance on international partnerships and other entities. No one country can do it alone, but also Harry's last slide did, I think, do a nice job of articulating some challenges that we're going to have, and maybe particularly on this last question, just with an eye towards, what's the private sector responsibility, and what are their responsibilities to their stakeholders, and what are the public good aspects, so the government responsibility. And I think actually with declining federal dollars, we sometimes lose sight of, what the public responsibility is for public good. So there's a way that more broader partnerships can help. That's good. I'm not, I do see one other question. So look, is it Daryl? Yep.
We'd be happy to get those copies to the staffers.
Daryl just suggested required reading of the new book that's going to be launched this afternoon on the legacy. And then I think also just remembering that the values, the economic value isn't necessarily in the data, it's in what people use of the data. Because I do remember from the 80s, even those 53 scenes a day went down to 5 scenes a day. So there was an order of magnitude decrease when the price of that imagery went up, and so when you went to selling. So, okay, listen, thank you. Could we just, Tom, you want to say something? Yep, go right ahead.
Just I want to, as you go to the break, just somewhat of a warning, if you will. We have invited, as part of our STEM outreach, middle school age kids to join us in the exhibit hall today. So when you walk in there and find 200 plus kids running around, welcome them and talk to them and help them enjoy their experience for us, please.
Our future astronauts.
What Tom meant was 300 middle school kids don't expect to have any food.
Right. Right. You guys, if we could just give the panel one more round of applause. I think they did a great job. So thanks. Mike, thank you.